So the Intergovernmental Panel on Climate Change is perhaps one of the most conservative scientific bodies on the planet. They rely only on the refereed journal literature. By the time they put out their assessment, which is conducted based on consensus by the scientists in the groups, and then vetted through the political process. So by the time the information comes out, it's 7 to 10 years old. As one example, in their vaunted 5th assessment, officially out last year but heavily leaked beginning in September of the year before, the word methane appeared twice in a single table. Methane is an unbelievable contributor to heating of the planet, with more than 100 times more heating potential than carbon dioxide molecule for molecule in the relatively short term, meaning less than 20 years. And it barely warranted a mention in the several hundred-page document put out by the IPCC. Because the information about methane wasn't out until relatively late. Still, the IPCC, the Intergovernmental Panel on Climate Change, concludes in their 5th assessment that global warming is irreversible in the absence of massive geoengineering of the Earth's atmosphere. This is an amazing admission for a conservative body. A half a dozen refereed journal articles appeared after the assessment came out, pointing out that geoengineering is in fact fantasy technology, as correctly reported by Truthout in April of last year. The chief of NASA indicates that we need to get to Mars, and relatively soon, by 2030 or so, because of lack of habitat here. Elon Musk of Tesla fame concludes that that's not fast enough, that we have to get there by 2024. So these apparently are desperate times, calling for desperate measures. I'm going to give the short version of the presentation in the next 3 slides, and we can just stop there if you want. I hate this first slide. It really should say the history of humans, but we're an incredibly misogynistic society, so I'll go with it. This is us pondering. Well, that was fast, wasn't it? Yes, it was. About 200,000, maybe 250,000 years of Homo sapiens, the self-proclaimed wise ape. That's how long we've been on the planet. Less than 1/7 as long as the typical mammal species. Homo sapiens, the self-proclaimed wise ape, I think that's a really poor choice of names. I think Homo calidus would have been a better idea. We're very clever. Calidus is the Latin for clever. Sapiens, wise, not so much. Yes, we're clever. I don't think we're so wise. I think we're headed for human extinction as a result of climate change. We haven't had humans on a planet at 3.3 or higher above baseline in the past. Baseline meaning the beginning of the Industrial Revolution, or about 1750. The highest temperature we've seen was during the Eemian, which is an extremely bizarre event, and it took thousands of years to reach 3.2 degrees centigrade above baseline at that point. We're headed for more than 3.5 C above baseline in the quite near future, and I suspect human extinction will result not because we're not clever, but instead because we don't have habitat. Like every other organism on the planet, we need habitat. And the most important of the habitat requirements, in addition to air, are water and food. And it's difficult for me to imagine that we will have much food with a rapid rise in global average temperature to 3.5 C or more above baseline. And by rapid rise, I mean within the next 18 months to 20 years. We will experience temperatures much higher than 3.3 above baseline. We need habitat. As an example of how quickly we could lose habitat for our species on this planet, let's say, for purposes of discussion, that collapse of industrial civilization, which has been going on for quite a while now, every macroeconomic measure with which I'm familiar peaked in 1999 or 2000. Not surprisingly, according to BP data, we hit the undulating plateau oil extraction in 1998. So let's assume we have a Soviet Union-style collapse after a relatively long and gradual decline with respect to the industrial economy. I'm not making a prediction that collapse of industrial civilization will be complete this year. I'm just pointing out the most rapid means by which humans could go extinct on this planet. So, if collapse of industrial civilization leads to a 1.2 plus or minus 0.2 degree temperature rise because of the absence of particulates in the atmosphere that cause dimming here on the surface of the Earth. So we have a bunch of particulates that we're putting up into the atmosphere as a result of industrial activity, most notably sulfates from burning coal. And those provide as something of an umbrella for the planet, a shading influence, if you will, from incoming solar radiation. It's called solar dimming, and BBC did a special documentary on the topic in, I think it was 2007. This from a paper in Atmospheric Chemistry and Physics by James Hansen and colleagues in December 2011. Two subsequent papers have demonstrated the very conservative nature of that particular paper. And so I think it's safe to assume that we'll hit at least 1.4 C above baseline with collapse of industrial civilization. In addition, we'll see the catastrophic meltdown of the world's 442 nuclear power facilities, which means exposure to the atmosphere of the spent fuel rods in the 1,200 spent fuel ponds around the globe. Because when the industrial economy collapses, people are not going to be going to work anymore. They're going to spend time with their family and loved ones. Even first responders give up after a few days and go to be with the ones they love. And so what that means is the water runs out of the spent fuel ponds and the rods are exposed to the atmosphere, and we have the kind of fires that this planet has never witnessed, spewing ionizing radiation throughout the globe. But enough of that. I want to talk about climate change instead. If we experience an abrupt termination to the most omnicidal set of living arrangements ever witnessed on this planet, industrial civilization, then I don't see any way we can prevent that 50 gigaton burst of methane coming out of the Arctic Ocean, predicted by Natalia Shikova to be, quote, highly possible at any time. Because with that rapid warming associated with the collapse of industrial civilization, we're going to have an ice-free Arctic. We might this year anyway. And with an ice-free Arctic, I just don't see keeping a cap on the methane from coming out in a very rapid manner. So what that means, we're at 0.85 degrees above baseline, beginning of the Industrial Revolution right now. The collapse of industrial civilization adds at least 1.4 degrees to that. That 50 gigaton burst of methane that's highly possible at any time adds conservatively another 1.3 degrees. So that takes us to a little over 3.5 degrees above baseline, about a third of a degree higher than humans have experienced on this planet, with more than 75% of the increase in temperature resulting in a year and a half or so. Already, according to a paper in August 2013 in Ecology Letters, evolution by natural selection is being outstripped by climate change by a factor of 10,000. Plants and animals cannot evolve rapidly enough. So evolution by natural selection certainly isn't going to keep up with this kind of temperature rise over a relatively short period of time, like 18 months. That said, the general consensus among the scientific community is that 4C drives us to extinction, 4C above baseline. Or at least that was the consensus until it became clear that 4 degrees was locked in. Within the last year or so, it's become clear that 4C is a given, no matter what we do. And so now the mainstream scientists have switched their tone a little bit and said, we can survive 4C. I don't know how, but 5 or 6, that might be problematic for our species. According to the Proceedings of the National Academy of Sciences, climate change is irreversible. This is from February 2009, 6 years ago, more than 6 years ago. And what the paper finds is that the heating associated with the current level of carbon dioxide in the atmosphere, which at the time was 385 parts per million, was locked in for at least the next 1,000 years. And so now we're at more than 400 parts per million, setting a new record every season for the last many, many seasons. And according to the United Nations Environment Program, during 2008, the most catastrophic year of the global Great Depression, or recession, we don't call them depressions anymore because that's too depressing, but during the Great Recession, when the industrial economy slowed to a virtual halt, emissions reached an all-time high. So just slowing emissions by slowing economic activity is insufficient. Of course, the record was broken in 2009, 2010, 2011, 2012, 2013, and 2014 as well. And I'm pretty sure we're not done yet. So it's become abundantly clear that only collapse of industrial civilization prevents runaway climate change. This paper, published in November 2009, was written in 2007. And several people asked me if Tim Garrett, the author of this paper, if that's what he really meant, what does he mean by collapse of industrial civilization? So I sent him an email message and I asked him. And he said, he confirmed that what that means is no food at the grocery store, no fuel at the filling station, and no water coming out of the municipal taps. Civilization is a heat engine. And it doesn't matter if we power civilization with solar panels or wind turbines or wave power on the coast, civilization itself is a heat engine. Only stopping civilization prevents runaway climate change. And this paper, written in 2007, was written and then published before we had any of the information about runaway climate change as a result of methane in the atmosphere. According to the Astrophysical Journal, for the entire history of the field of astrophysics, astrophysicists believe that we were right in the sweet spot, right in the middle of the habitable zone, right in the middle of the green zone for a sun with the intensity of our sun. But in fact, as it turns out from this relatively recent paper, we're right at the inner edge of the habitable zone. You can see Mars on the right, barely in the habitable zone on the other side. And you can see Venus, the yellow plus sign, just to the left of Earth there. And we know what happened to Venus, right? It went Venus with respect to its atmosphere and became lifeless. And so if we are within 1% of the habitability for a star the likes of our sun, what that means is a relatively minor change in atmospheric chemistry might drive this planet beyond the habitable zone. And this is the bummer part. We haven't made minor changes in atmospheric chemistry on this planet. We've made major changes, increasing carbon dioxide more than 40% since the beginning of the Industrial Revolution, to a level never experienced by humans before, and increasing methane by more than 200% since the beginning of the Industrial Revolution, more than 200%. And again, methane is more than 100 times more powerful a greenhouse gas than carbon dioxide over relatively short temporal spans. And contrary to the contrarian myth that there's been some sort of pause in warming, I'm sure you've heard this from your climate denier friends, in fact, heat has been increasing and it's been stored in the ocean. So yes, land records actually paused, sort of, for a time after 97, 98, the last time there was a big El Nino event which causes the heat to come out of the ocean and on the land. But the ocean is an enormous battery. It stores carbon dioxide and it stores heat. And look what's happened since 97, 98. Heat intake by the ocean has gone up dramatically, even in the deep ocean, more than 700 meters down. There's been an enormous rise in heating. So with the next El Nino, which is underway right now, albeit a weak El Nino currently, there's going to be a lot of heat that comes out of the ocean and overwhelms the land masses. Never mind methane. The amount of carbon dioxide and heat that is stored in the ocean right now is sufficient to cause all sorts of trouble for us in the not too distant future. I want to talk about one of the self-reinforcing feedback loops that have been triggered and that we've become aware of in the last 6 years or so. So I'm going to talk in some detail about methane bubbling out of the Arctic Ocean. The first time it was reported in the referee journal literature was in August 2009, when about 250 plumes of methane hydrates were escaping from the shallow Arctic seabed, likely as a result of a 1 degree increase in temperature. Well, since then, the temperature of the Arctic has been increasing at more than twice the rate of the global average. So the Arctic is warming much more rapidly than the global average, than the rest of the planet. And that helps explain the Rossby wave or meandering jet stream, or the polar vortex that you likely have heard about, that has been blamed for the never-ending drought in California, and also for the record cold and snow experienced on the eastern seaboard over the last couple of winters. Science comes along a little less than a year later and has an article reporting impacts of methane hydrates, the importance of those methane hydrates. Methane hydrates or clathrates represent cages around methane molecules. So methane is CH4, or natural gas, and in the shallow Arctic seabed and in permafrost, they are trapped by a clathrate or a chemical cage. And when that clathrate warms, it breaks open, and CH4, methane, is released into the water column, or worse, into the atmosphere. And so when you see the term hydrate or clathrate, that's what we're talking about, is those chemical cages. Geophysical Research Letters gets on board in 2010, and finally, in a paper by Michael Jennings at the University of Idaho, we see an admission in the refereed journal literature that a suite, not just one, but a suite of amplifying feedback mechanisms or self-reinforcing feedback loops, or so-called positive feedbacks, such as massive methane leaks from the subsea Arctic Ocean, have engaged. So the self-reinforcing feedback loops are underway. These are feedback loops that feed upon themselves. So the faster they go, the faster they have the potential to go. A good example is ice on the Arctic Ocean, floating ice on the Arctic Ocean, which has been in decline since the beginning of the Industrial Revolution, and most notably within the last 34 years or so. And as the ice gets smaller, it reflects less radiation back up into space, and that open blue water absorbs more of that radiation. And the more it absorbs, the warmer the ocean gets, and so the faster the ice melts, and the faster the ice melts, the less albedo we have, the less reflectance we have going back into space. So it's this mechanism that feeds upon itself. The faster it goes, the faster it's able to go. According to the author of a paper in Nature, July 2013, this is Natalia Shikova, who's been doing field work along with her research partner Igor Sameletov in the Arctic Ocean for about the last decade, and she concludes that a 50 gigaton burp of methane is, quote, highly possible at any time. There would be a 1.3 degree temperature rise conservatively associated with that burp of methane. Finally, NASA gets on board and observes methane plumes up to 150 kilometers across in the Arctic Ocean summer before last. This is huge. You imagine you're in a ship, you're in a sailing ship in the Arctic Ocean, and as far as you can see, every direction, the ocean is bubbling. It's bubbling like beer or like ginger ale, like carbon dioxide is coming up, but it's actually bubbles of methane that are coming out. As far as you can see in every direction. So observe that quickly, because when you start to breathe that in, you're not going to last very long. Nature Geoscience gets on board, points out that storms accelerate the methane release. Eastern Siberian Arctic shelf is venting a lot more methane now than it was not very long ago, according to this paper. Sam Carana concludes the global average temperature will be above 4°C by 2030 and more than 10°C by 2040. And I want to make a distinction here. When I give the name of a journal or an organization such as the Intergovernmental Panel on Climate Change or NASA from the United States' National Aeronautic and Space Administration, those can be found mostly in the refereed journal article or are put out by the organization. These other ones that have the name of an individual represent projections made by individuals, and they are not published in the refereed journal literature. So quite a clear distinction there. According to Malcolm Light, retired Earth system scientist now living in London, I believe, the Gulf Stream transport rate started a methane hydrate or clathrate gun firing in the Arctic in 2007. So the gun was fired many years ago. According to Paul Beckwith, climate scientist at the University of Ottawa in Canada, we can expect, based on historical events, a 5 to 6°C temperature rise within a decade or two, and he actually pondered a 16°C temperature rise within that same period of time, albeit with respect to the previous ice age. So that's 11 or 12 degrees higher than it is right now. And that makes sense because those are the relatively stable states that Earth has experienced throughout its history. We have ice ages. We have 5 or 6 degrees warmer than ice ages, and we have 11 or 12 degrees warmer than ice ages, and maybe one other one in there. But these are the relatively stable states, and Earth doesn't go gradually from one to the other. The changes tend to be quite abrupt from one relatively stable state to the next. And it could be that we've actually triggered a Venus-style event. It could be that we haven't as well, that Earth will stabilize at some relatively modest temperature, like 5 or 6 or 11 or 12 degrees above where we're at right now. So if we look at methane, atmospheric methane levels, you can see an exponential rise, which stabilized in about 2000 and plateaued for a bit, and consequently has gone up pretty seriously since then, as you can see here, with the Clathrate gun, according to Malcolm Light, fired in 2007 at the very beginning of this exponential curve. And you take a look at the sources here, and these are not wacky political types drawing some conclusions about atmospheric methane. This is NOAA, and this is the UK Met Office. Okay. And what Sam Carana has done is extend this line straight up, assuming that we've triggered a runaway event, a Venus-style event. And Paul Beckwith says, no, we haven't. It's going to stabilize at some lower temperature than Venus. And so this is Carana's projection. And I like to use the quote by Albert Bartlett, longtime professor and then professor emeritus at Colorado University: the greatest shortcoming of the human race is our inability to understand the exponential function. We just don't think, and we don't feel, and we don't act exponentially, right? And throughout our entire history, as a species and as individuals, we project into the future based on what has happened in the recent past. That's how evolution works. Evolution by natural selection, and that's how psychology works at the individual level. We think that the near future will be pretty much like the recent past, because the exponential function is just pretty difficult to wrap our minds around. I take issue, though. I don't think the greatest shortcoming of the human race is our inability to understand the exponential function. I think the greatest shortcoming of the human race is our inability to understand. Period. We don't even understand each other. We don't understand ourselves. We don't take time to ponder our place in the universe, to figure out that, in fact, we're a speck on a speck on a speck, that in the 13.8 billion years of the universe, our species has been here for a couple 100,000 years. In light of that knowledge, which most people tend to not think about because it's kind of a scary thing, it forces us to draw the conclusion that the whole thing maybe isn't about us. Maybe the universe was not designed just for humanity. Maybe the universe didn't arise with humans in mind. We just showed up. We just got here, and in our hubris, we think it's all about us. It's not all about us. It's not as if I like collecting this information and distributing it. I haven't conducted primary research for 6 years since I've left active service at the University of Arizona. So instead, since that time, I've collated the information put out by other people and put it together and connect a few dots and put it out. So everything I'm citing is work that's been done by other people. It's not really my opinion. This is my opinion. Everything else comes from somebody else. So I've talked about the one self-reinforcing feedback loop that based on the refereed journal literature was triggered in 2009. There are others, 47 that I know about so far, almost all of which are reported in the refereed journal literature, and you'll notice that the number of them is increasing as time goes by as well. And I thought when we were at 20 of them, I thought there's no way we could get more, because everything that happens after this surely fits into one of those other categories. And I thought the same thing at 30 and then 40, and I think the same thing now. We can't possibly have any more, because everything that happens is going to fit into the category of firing the Clathrate gun, or land-based permafrost turning into permamelt, or boreal peat disintegrating and generating carbon dioxide directly into the atmosphere, or any of a number of other factors that I think I've already counted all of, but I've thought about that before. Mistakes have been made. Farley Mowat, the writer, says we're under some gross misconception that we're a good species going somewhere important. At the last minute, we'll correct our errors and God will smile on us. It's delusion. Well, it's no longer the last minute. The last minute probably was the year 2000 or before. It certainly was before we fired the class rate gun. We now know that maximum heating associated with carbon dioxide release occurs in about 10 years after the carbon dioxide is emitted into the atmosphere. So we have not experienced maximum heating associated with the last 10 years worth of carbon dioxide emissions. That hasn't hit us yet. And of course, during the last 10 years, we've emitted more carbon dioxide than in any other 10-year period in the history of the planet. That's just carbon dioxide. That doesn't include methane. And it appears to me that methane really is running the show now. Lest you think I'm the first crazy person on the planet, I'm not. There are a bunch of other people, all of them way smarter than me, that believe we're headed for human extinction in the relatively near term. And these range from project managers for a large IT organization who just connects the dots in her spare time to really smart people like Noam Chomsky, who's not a climate scientist, to biologist Paul Ehrlich, conservation biologist, to television writer Aaron Sorkin, and then a few climate scientists, anthropologists, and random scientists in the mix as well. Randy Malamud is an interesting story. Regents Professor of English at Georgia State University in the United States. And I interviewed him for my radio show and just assumed, since he had just had an essay published in Huffington Post, just assumed that he'd been reading my work. And so I asked him, how'd you come up with this? He says, I've been studying what we do in zoos for a long time. So this is a professor of English. And he says, I see what we do to other animals. We put them in cages and we treat them really badly. And we do the same things to ourselves. How could we not go extinct? So he got there by a completely different route than I did. He didn't even know that climate change was really an important thing. What now? Well, I have really good news. I would hate to finish dissimilar from a Hollywood movie. I have to give you the good news at the end. And I have really good news. We get to die. And that's astonishingly good news because it means we get to live. The odds against that happening are truly cosmological. We know a lot about DNA. We know so much about DNA that, for example, we know the odds against any one of us coming together in physical form exceed the odds against plucking a single atom at random from the entire universe. And yet, here we are. Here we are, as evolutionary biologist Richard Dawkins says, it is you and I that are privileged to be here, privileged with eyes to see where we are and brains to wonder why. It's amazing. Against all odds, here we are. We get to live. Contrary to what you've read on the internet, I am not the leader of a death cult. I'm not the leader of anything. If you're looking for a death cult, that would be industrial civilization. That's the death cult. Industrial civilization drives to extinction 150 to 200 species a day, according to a United Nations report about 5 years old, and undoubtedly conservative. 150 to 200 species a day, that's not me. That's us in the collective. And I'm not the leader of us in the collective, or there would be more than 40 people here, I'm sure. We foul the air and dirty the water and erode the soils into the ocean, and civilization allows all of that. We use nuclear power to boil water. And we wonder why it's not the same planet we grew up with. In the teeth of these stupefying odds, it is you and I who are privileged to be here, privileged with eyes to see where we are and the brains to wonder why. It's amazing. Instead of being the leader, and as an anarchist, I take offense with that term, of a death cult, I propose that we pursue a couple of things, and I think that they're not bad ideas. whether or not we have triggered abrupt climate change. I suggest that we pursue what we love, and we pursue, for whatever this means for you, a life of excellence. For me, inspired by Socrates, who I admit might well have been a figment of Plato's imagination, for me, a life of excellence means asking questions. You know, Socrates just spent his entire adult life asking 6 questions in various forms. 6 questions. What is courage? What is good? What is justice? What is moderation? What is piety? What is virtue? 6 questions. And then finally, at the age of 70, they killed him for it. I should be so lucky to live to the age of 70 and to be martyred for asking questions. That would be awesome. That's what a life of excellence means to me. It means asking questions. Asking every question I can think of about this omnicidal culture. About what the hell are we doing? About what am I doing? What is my place in this vast universe, in this grand play? What would possibly make me think that I'm important, or much less our entire species? And I'm a civilized white man, so already I think I'm pretty damn important. Pondering the questions. I don't know what a life of excellence means for you, but I encourage its pursuit, whatever it is. Frequently I get the, what if he's wrong? No, I don't get it asked as a question hardly ever. It's always a statement. 2 words, he's wrong. And it could be that all the data I cite, that all the sources I cite, that all the references, that all the models, that all the projections, that they're all wrong. It could be that the International Energy Agency, an incredibly conservative source, it could be that their projection of business as usual leads to a 6°C temperature rise by 2050. That could be wrong. It could be that Paul Beckwith is wrong in making his forecast that as a result of methane, completely ignored by the International Energy Agency, that the temperature rise is going to be a little bit faster than predicted by the IEA. That could all be wrong. So what? Even if I'm wrong, we get to die anyway. Ain't it awesome? We get to live in the teeth of these stupefying odds. It is you and I that are privileged to be here, privileged as the eyes to see where we are and brains to wonder why. It's pretty incredible when you think about it. Most people don't, but if you do, I suspect, by the way, that it's not going to seem like a long time for any of us. For example, the world's oldest person turned 117 in just about a month ago, and when asked to ponder the last 117 years, she says it seemed rather short. And then she died last week. It seemed rather short. I used to say, even if you live to be 100, you're going to take a few memories into the abyss. It's going to seem rather short. When you're there in your deathbed, you are not going to be thinking, damn, I should have bought more shoes. Then I suspect you're going to be thinking something completely different. You're going to be thinking, maybe I should have contributed to more joy in the lives of the people around me. I don't think anybody's going to be saying on their deathbed, I should have bought more crap. I think that my primary message, which is to pursue love and pursue excellence, is a decent, legitimate set of suggestions, regardless of what happens in the future. You know, hope and fear are the twin sides of I don't know the future coin. And we can act on hope that somebody is going to make things different than it appears they're going to be. We can act on fear that the world is going to be different in the future than it is right now. Or we can live right here, right now, and treat each other with dignity and respect and decency. And so what I'm suggesting is that we actually live here now. That we act with decency towards each other, with respect towards each other, even if, especially if, we're all going to be dead in the not very distant future. So I think pursuing love and pursuing excellence and acting with decency and kindness and compassion is never really a bad approach. And of course, there are people in every society that think otherwise. And they'll always be with us as long as we're in groups of more than 200 people or so. But that's just the way the system works. That's the way civilization works. is that there will be this vast difference between the takers and the leavers, between those who have and those who have not. But that doesn't mean we have to become them, just because the system inspires us to take off in that direction. Somebody once asked me if I could wrap up in 3 sentences my whole message. So I said, how about 3 words? Live here now. Thank you very, very much for coming tonight. I really appreciate it.